Today we're going to do the distributive property, lesson 5.4. So let's look at the real world link. School supplies. Jordan buys 3 notebooks that cost $5 each. He also buys 3 packages of pens for $6 each. So this is write an expression that shows the cost of 3 notebooks added to the cost of 3 packages of pens. So how do we do this? Well, we notice that for each of the items, we're supposed to do 3F, so we can put a 3 in the first box and a 3 in the second box. So the next thing it says is write an expression that shows 3 times the cost of 1 notebook and 1 package of pens. So if we write that using a distributive property, we can use 3 because we're going to multiply 3 times 5 and 3 times 6. Now it says evaluate the expressions. What do you notice? Well, if we multiply the first one, we have 15 plus 18, and that would equal $33. If we look at the second one, we do 3 times 5 and 3 times 6, or we can add 5 plus 6, which is 11, and then multiply 11 times 3, which again equals 33. So if we compare the two, you can see that the answers are the same. Let's look at the second part of it. So, suppose Jordan buys 5 notebooks that cost $3 each and 5 packages of pens that cost $1 each. Circle the expression that represents Jordan's purchases. Well, this one says 5 times 3, so 5 notebooks at $3 plus 5 notebooks at $1. So yes, that is the same. 5 notebooks at $3 times 5 notebooks at $1. So this does not work. And we have 5 times 3 at $3 and 5 times 1 package of pens. And again, this one works as well. Lastly, suppose Jordan buys 2 rulers that cost $1 each and 2 folders that cost $1.50 each. Circle the expressions that represent Jordan's purchases. Here we have 2 plus 1 plus 2 plus $1.50. So these are all adding. And we don't have any groups in this first example. These are all just adding each item separately. Now this one asks for, we're multiplying the 2 because we need 2 folders, and we're multiplying folders that cost $1.50, and we're multiplying 2 that cost $1. So in this case, it does fit the example. And here we have 2 plus 2 times $1 plus 2 times $1.50. And again, we have 2 groups. So we have the 2 of the dollar and we have the 2 of the $1.50. So again, this one would fit the bill. Our second example, we go over the definition of distributive property. As you see, the distributive property states that to multiply a sum or a difference by a number, multiply each term inside the parentheses by the number outside the parentheses. And it gives us an example. We have, again, we're taking this first value, we're multiplying it by each item inside the parentheses, but we're not changing the operation that falls in the middle. And again, when with subtraction, we're doing the same thing. We're multiplying each part of the parentheses while maintaining the operation in the center. So let's look at our examples here. As we did in class, the first example, it says use the distributive property to evaluate 8 times a negative 9 plus 4. So we multiply each piece, and we're essentially writing it like 8 times a negative 9 plus 8 times 4. So we keep our integers constant, and so we have a negative 72 plus 32, and when our signs are different, then we find the difference of the value and keep the sign of the bigger number. So that equals 40, and the sign of the bigger number is a negative, so the answer is negative 40. Let's try these examples here. Again, we're now distributing out our value. It would be 5 times a negative 9 plus 5 times 11. So we'd end up with a negative 45 plus 55. The values have different signs, so we find the difference, which is 10, and we keep the sign of the bigger number, which is the 55. So our first answer would be a positive 10. Moving on, we have the second value would be 7 times 10 minus, because we don't change the operation, minus 7 times 5. So we come out to be 70 minus 35, and our answer would be a positive 35. Next, lastly, we would have, this doesn't change when a value is on the other side of the parentheses. We still approach it in the same way now. So we're at 9 times 8. And that would be 9 times 12, which would be 108. Or we could write it 9 times 12, which is 108. So we'd have 108 subtracted from 9 times 8, which is 72. And our answer would be positive 36. Looking at page 377, again, we are simply distributing out. This time, though, we have variables. So if we look at our first example, which is D, again, we're just distributing out. So we have 6 times A, which we know we can write just as 6A. We don't do anything with our operation. We keep that the same. So we have 6 times A plus 6 times 4. So our answer is 6A plus 24. And there's nothing else we can do. We have all of our like terms coupled together. So our answer would simply be 6A plus 24. On E, again, when we have our number on the back side of the parentheses, it doesn't make any difference, so we're going to distribute these out. So it's 8 times M, and again, we don't do anything with our operations, we purely put it in there. And then we have 8 times 3N, so 8 times 3N, so now we write that out. 8 times 3N would be 24N. And again, we're finished because M and N are not the same variable, so we cannot add those together. So we would just write 8M plus 24N. Next, we have F. f, we would have a negative 3 times y, and our operation's a minus, and then we'd have a negative 3 times 10, so it would be a negative 3 times 10, and when we write that out, we have a negative 3y minus a negative 3 times 10, which is a negative 30. And we can simplify this a little further by saying a negative 3y plus 30, because we don't subtract, we add the additive inverse. So our final answer would be negative 3 plus 30, negative 3y plus 30. Our last example, G, is 1/2 times W, and we distribute that out, minus 1/2 times 4. So as we simplify that, we have 1/2 W minus 2. And there would be nothing more we could do with that, so that would be our answer, 1/2 W minus 2. Remember, you cannot add a W term to a number. You can only add a W to another W. Same with the Y, and again with the A, and the M and the N. We have to look at those variables separately. If it's an N, it can only be added, multiplied, divided by other N's. If it's an M, it can only be added, multiplied, divided by other M's in that problem. The last part of our lesson for today is the word problem, and this particular word problem, we have H. The sports club rents dirt bikes for $37.50 each. Now, as we looked at this sample above, we can break out a larger sum, such as $19.95, or in this case $37.50, into smaller parts so that we can do our mental math a little quicker. So in this case, it says justify your answer by using the distributive property. So basically what it's saying is we have the $37.50, and we can break that into 37 plus 50 cents. And we can multiply both those sums by 20. So if we multiply 20 by 37, we get 740, and then if we multiply 20 times 50 cents, that would come out to $10. So we can then add this quickly together, and we come out with $750. Hope that helps. See if you can do the guided practice on your own.